Okay, so as we've talked about, this entire unit is about collecting data. So far, we've talked about surveys. Either a survey that you like mail out to people, or you stand outside a store and pass the survey out as they're walking in. What we're going to talk about and focus on the rest of the unit is experiments. There's a lot of vocabulary that comes along with an experiment. So the idea of imposing a treatment. So we're going to talk about that vocabulary, how to design an experiment, what some limitations are, what kind of conclusions we can make. That's what we'll talk about between today and next class. You don't need a calculator, so if you have one out, you won't need it. This is where I need you to find. So hopefully we already are on this page. If not, if you could find it, I believe it's page 12. So we're going to use this portion of an article based on a study and kind of go from there. Based on a perusal of the vitamin section of most drugstores, you would think that Americans need a lot of vitamins, and almost 50% of adult Americans reported taking some dietary supplement, according to the most recently published data in the 2009 to 2010 National Health and Nutrition Examination Survey. People take specific vitamin supplements, of course, B, C, D, E, and so on, and if taking one vitamin at a time is too much, one a day multivitamins abound, designed for each specific life circumstance. To understand how we got to that endless row of vitamins at CVS, it's useful to look at a couple of examples, vitamin D and vitamin E. These are among the most popular vitamin supplements. In the 2009-2010 survey, 34% of adults reported taking vitamin D and 30% reported vitamin E. One can find plenty of support for this supplement behavior in the medical literature. A recent review identified 290 observational studies on vitamin D. For the most part, these studies measure the amount of 25-hydroxyvitamin D, the marker of vitamin D concentration, in participants' blood, and analyze the relationship between that concentration and various measures of health. Using this approach, researchers have found that higher concentrations of vitamin D are linked to less cardiovascular disease, lower overall mortality, less weight gain, less diabetes, blah, 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 blah. That's what we're going to go off of. Okay, first question. What does it mean for two variables to have an association? It means that knowing the value of one variable helps predict the other. So this was the idea we saw with regression. We said there is an association or relationship between x and y. What that means is, if we know the value of x, it helps us predict the value of y. It's the same idea here. Oftentimes, we're not going to be looking necessarily at numbers. It might be more categorical variables. Just for you to know what's coming up, as was written or we read about earlier, this idea of observational studies, those are different than experiments. So that's kind of what we're going to talk about today, is what is the difference between an observational study and an experiment. Okay. So based on this excerpt, can we conclude that taking vitamin D causes the great health benefits? So it says that people who are taking vitamin D or who have a higher concentration of vitamin D, they have less cardiovascular disease, less mortality, less weight gain, so on and so forth. Do you think that all of that is solely because of the vitamin D?
No.
Why not?
If I'm correct, it comes, you get vitamin D from, the sun, so, if you're spending more time outside, you're also exercising more or whatever, which could also link to the positive benefits.
Yeah, are there possible differences between these groups of people besides just vitamin D?
Yes.
Right? Maybe one group exercises more, maybe one group spends more time outside. What could be another benefit that might be the case for these two groups, or one difference, rather? Yeah, maybe one group eats healthier. Right? Is that going to be the case for every single individual in the vitamin D group versus the other group? No, but generally.
The only thing I know about vitamin D, based on my own experience, is that it helps you with keeping your energy up
Which might cause then other things like the eating healthier or the working out.
The human body is absurdly complex.
Yes.
It has I have no clue how many variables going in and out of it.
So there is this idea of confounding variables. That just means other variables that affect the health. Besides vitamin D. And so let's look at these two groups that we have in the table. So some things to look at. Group 1 has a lot of vitamin D. Group 2 has less vitamin D. So then vocab-wise, our explanatory variable is the vitamin D concentration. And the response variable that we are measuring are their health outcomes. So then this portion of the table are any other differences that might be inherent between the two groups. So these would be examples of those other variables. So one that Kiara mentioned was exposure to the sun. Maybe group 1 spends lots of time in the sun. Whereas group 2 gets little sunlight. She also linked that to exercise. So it's possible that the people who have a high vitamin D concentration tend to exercise regularly. Again, it's not going to be true for every single case for every single person, but in general. And it's possible that group 2 tends to not exercise regularly. And then Will mentioned diet. It's possible that group 1 eats more healthy. Whereas group 2 eats less healthy. And so now we see there are 4 differences between these two groups, 4 kind of explanatory variables that are differences. There is no way for us to know what caused the difference in these health outcomes. Is it all 4 of these variables? Is it one variable more than the other? We have no idea. All we know is that there's a difference in these variables and these variables, but we don't know what the cause is.
From the expert at the very end, before Tresloff, it mentions the Philosopher's Stone, which is a reference to back in the days when alchemy was thought to be real. They thought there was this one substance that could turn lead to gold. They called it the Philosopher's Stone. That does not exist.
Okay, let's talk some more vocab. A confounding variable. So, in general, a confounding variable is we say 2 variables are confounded if it is impossible to determine which variable is causing a change in the response variable. Now, if we notice that's not what the question asked, the question asks us to explain confounding in the context of this study. And so what we have to do is we have to give an example. So we can say vitamin D, and then we choose another variable. There were 3 of them. I'm going to choose exercise. So vitamin D and exercise level are confounded because it is impossible to differentiate the effect of each on overall health outcomes. So again, we have these two groups. They have a difference in vitamin D. They have a difference in exercise. We don't know why there's a difference in the health outcomes then. Could be either of those two. Okay. What we have read about with the vitamin D is called an observational study. The big difference between an observational study and an experiment is an experiment imposes a treatment. So if we did an experiment with vitamin D, what that would mean, if you all were my subjects, is I would have to tell each of you, yes, you are taking vitamin D, or no, you are not. I'm not just observing your behavior, but I'm telling you specifically whether you are taking vitamin D or not. So if we're just observing people's behavior, that's an observational study. If we are imposing a treatment of some kind, that's an experiment. Here is why that actually matters. An experiment, because it imposes a treatment, shows cause and effect. An observational study, because there is no treatment, can only show a correlation between two variables. Can only show a correlation between two variables. And so we will talk about, there's a few different requirements for an experiment, but the rest of class, what we're going to focus on is the vocab in an experiment and how to design an experiment. Questions right now? Okay, so we're going to finish this page and then we will take a break. So we're going to move into designing experiments. We're going to design an experiment to see if fertilizer affects the productivity of tomato plants. So here's an initial plan. Plant the tomato plants, add fertilizer to all of them, water the plants, and then measure the growth after 2 weeks. Again, what we care about is, does the fertilizer affect the productivity of these plants? Okay, what are problems? Avery? Okay. I don't know why this says pulse rates. That should be productivity. But yes, huge issue. There's no control group. Avery, what do you mean by control group?
There's nothing to compare the growth to.
Yeah, we have nothing to compare to. Isn't there reason to believe that these plants are going to grow anyway?
Unless
You don't water them or something.
unless something other variable happens, it's reasonable to expect they will grow.
Yeah, they're going to grow anyway. So now we're adding this fertilizer. We have no way of measuring or knowing if they're growing more due to the fertilizer. What else?
It just says water plants. Should be water them. It shall be. If we're just wanting what the fertilizer does, we should be watering all of them the exact same amount.
Okay, so what other variables are likely to be sources of what else affects the growth besides this fertilizer? That's a big one. Water. Right? Are they all getting the same amount of water? Are they being watered at the same time? If we water some of the plants every day and some other plants once a week, that's going to be a big difference. Sunlight. Are they all getting the same amount of sun? What else?
The soil.
The soil. What about the type of tomato? Like, are we using all of the same tomato plants? What about where they are outside? Not just sunlight, but like, are there pests that have access to them? Okay, so we are going to start by, or continue by addressing some of these issues. The first one is that we are going to include a control group. The control group does not receive fertilizer, like Avery said. The purpose of the control group is it provides a baseline for comparison. Provides a baseline for comparison. Okay, so keep going with, continuing with our vocab for experiments. Let's talk about the placebo effect. Placebo effect is when people, generally people, unintentionally, I guess, or intentionally, modify their behavior due to believing they are receiving a treatment. So a lot of times you hear about this with drug trials, that particularly drug trials, let's say for like depression or anxiety, that a lot of times the two groups, one group will get a drug that has an active treatment, and one group will get a drug that's just a placebo that is like a sugar pill that does nothing. But people still, their depression will get a little bit better, or their anxiety will get a little bit better because they're taking a pill and they think they should be getting better. Does that make sense? So that's the idea with a placebo.
It's all in your head, which makes I have no clue I have no clue how my brain works.
It is important to note that not all experiments have a control group or a placebo group. It's not always necessary. Depends on what we're looking at. So for our tomato plants, do they need a placebo? Are the tomato plants going to grow more because they think they should? No. Now, it depends on what we want with the tomato plants. We said our question in general is just, does the fertilizer affect the growth at all? Yes or no? Sometimes what we might want to know, though, is this fertilizer better than this fertilizer? Well, we don't need a treatment. We don't need a control group then. We would just have two groups, fertilizer A, fertilizer B. So in that case, we would not have a control group. Okay, when we are talking about blinding, blinding is the idea that either the subject or the person measuring the response variable does not know what treatment was given. Okay, so a single blind experiment. For, let's say we are comparing two different medications, like I said, for anxiety. We have medication A, medication B. Is it possible that if you all were the subjects, that I could give you medication and you wouldn't know which one you were receiving? That you would just take a pill? And all the pills look the same, and some are medication A and some are medication B. Possible, right? So that would be single blind. Double blind would be you don't know what treatment you're taking, and then the person measuring your anxiety doesn't know what treatment you're taking. Okay, every year people get confused by this. If the person doing the measuring doesn't know, and the person taking the medication doesn't know, who knows then? who has what treatment.
The person who gives
No one.
the pills, and they just hold that information to themselves until after they get all their measurements.
Yeah, just the person at the very top, like the person in charge of the experiment, has a list of all the people, what they're getting, and then they just give the protocol to everyone else. Does that make sense? You want to blind whenever possible. It's not always possible though. So for example, if we were comparing the effect of diet and exercise on your cholesterol, and some people we controlled their diet and some people we controlled their exercise, you're going to know if I'm giving you a specific diet or a specific exercise plan. So, not always possible. Okay, some more vocab. Really, what I need you to know here is experimental unit. That is a big one. The experimental unit is the single individual that receives the treatment. So like who is actually individually receiving the treatment. And then we have, of course, treatment and subjects. Are we okay on those? Factor and level. I'm not too concerned about factor and level. Factor is just the individual treatment. Whereas level is the amount of the treatment. So for the fertilizer, for example, I don't know how much fertilizer you use. Anybody a planter in here? What is like a normal amount of fertilizer on a plant? Can we just go with half a cup?
I was thinking like cup, half cup.
Yeah. So we could use no fertilizer, half a cup of fertilizer, a cup of fertilizer. So then we would say for our level, there are 2 levels for the fertilizer, half a cup and a cup. Really, the ones that you're going to see most often that are most important here are definitely treatment and experimental unit. So those are the ones that I need us to know best. Okay, so with our tomato experiment, what we've done so far is we've said we're now going to have a control group. So we have these tomatoes that we're going to plant. Some are going to get fertilizer, some are not going to get fertilizer. That's where we are so far. Now, we said, though, there's a whole bunch of things that affect productivity besides the fertilizer, like sunlight and the amount of water and things like that, what kind of tomato plant they are. So what we want to do is we want to make sure that our two groups, fertilizer and non-fertilizer, are as similar as possible. The way we can do that is with randomization, replication, and control. These are incredibly important vocab terms. Okay, what random assignment means is we randomly assign a treatment, so that is the fertilizer or the non-fertilizer, to each tomato plant. So each tomato plant will randomly be put into the group of either fertilizer or non-fertilizer. This is essential. The purpose is to create groups that are roughly equivalent at the beginning of the experiment. It tends to even out the effects of confounding variables that we can't control. So that's always going to be the case. There are always going to be confounding variables that we can't control. And so we hope that randomization will take care of that. Questions? Okay. So then how do we randomize? Generally, there are two preferred methods. One is slips of paper in a hat. Second one is a random number generator. You guys have to remind me that we did not go over homework. I meant for us to go over homework. I forgot to do that though, so we need to make sure that we do that. So either slips of paper or a random number generator is what I tend to do. Completely randomized design is exactly what it sounds like. You randomize the treatments. So when you see that, it just means all the treatments are randomized. So completely randomized design is an experiment where all treatments are randomized. It is possible to have an experiment that is not randomized. So it is possible to have an experiment where we assign treatments, but we did not do it in a random way.
And there's probably a reason for it.
Okay, if I were to ask you to actually randomize the tomato plants, I think it says there are 30 of them. So if we said, how are we going to do it? I would say, write fertilizer on 15 slips of paper. No fertilizer on another 15. Put in a hat and mix. So I'm writing fertilizer on 15, no fertilizer on another 15, put them all in a hat, and I'm going to mix them up. That mix is important. That is the random part. And then I would draw one slip for each plant. I am not going to use replacement. So what that means is when I take the slip out for the plant, I throw it away. It doesn't go back in the hat. That is what I do every single time. What is the key, though, that people forget is you have to say mix and you have to say don't use replacement. Even if there were 1,000 plants. It's not practical, but I don't care. And College Board, the AP test is also not going to care if your design is practical or not. Okay, two more things. What is replication? Replication means ensuring there are an adequate number of subjects in each treatment group. Show of hands, how many of you are in AP Psych? Okay, I should have said this at the beginning. Schaff and I try to do a really good job of telling you when there are differences in AP Psych versus AP Stats. And there are some terms that are used differently. A big one that is used differently is replication. In AP Psych, replication, bless you, means doing your experiment again. That is not what replication means here. So if you are in AP Psych, you need to be careful. Replication does not mean the same thing. What I mean is we can't just use 2 tomato plants. Bless you. If we have 2 tomato plants, one with fertilizer, one without, and there's a difference in growth, do we know that it's because of the fertilizer?
No, our sample size is too small.
Couldn't it be that just one plant was healthier than the other one? Yeah. So that's why we need to make sure that we have replication. We're going to finish this page and then we'll take another break. What does it mean to control other variables? We are going to hold those other variables constant. So for example, our plants are going to get the same amount of water. They are going to get the same sunlight. So either they're all outside in the same spot or they all have the same type of lamp, growth lamp. We are going to use the same variety of tomato. That's the idea of controlling other variables. And there are two main benefits. The first one is we are preventing the effects of other variables. So based on what we have written above, the amount of water now is not going to affect productivity. The amount of sunlight is not going to affect productivity. The type of tomato is not going to affect productivity. That is the preventing confounding. And then it reduces variability. So here is an example of that. If we applied any amount of fertilizer, like we just did it at random to the plants getting fertilizer, then the growth is going to be more variable. So that's another thing I should have said that we were going to control, is we're going to apply the same amount of fertilizer to each plant. The big key is at the bottom here. This is really a quick summary of what we just talked about. With random assignment, replication, and controlling other variables, each treatment group should be nearly identical, and the effects of other variables should be about the same in each group. Now, if there are changes in the explanatory variable that lead to changes in the response, we can attribute these changes to the explanatory variable. All that's saying is we can show cause and effect. So because we have controlled our other variables, we can show cause and effect. How do we feel about this? Vocab-wise, we feel okay? We ready for one more break? And then we'll design an At this point, we need to put it all together. So I'm going to talk for like 1 minute, and then you all will be designing an experiment. So here we go. Steps for designing an experiment. You have to decide what are your treatment groups. You're going to have to tell me who gets what treatment. So like you have 20 students that you're going to use. How are you putting them into treatment groups? What treatments are they getting? What are you measuring? And how are you going to make a conclusion? If you would write this, you must describe in detail the randomization process. So, are you going to use the slips of paper in a hat? Are you going to use a random number generator? Has to be specific enough so that I can carry it out. You also must give a few examples of variables you plan to control. So some things to think about. Are you going to have a placebo? Is this going to be a blind experiment? Well, you have a control group. So here is the experiment, you are designing. Several stats students wondered whether caffeine could improve test scores. So I'm going to tell you that you have 20 students to use in your experiment. Let's just decide together right now, what do we think the best treatments would be if we have caffeine and then something else?
Well, I'm thinking, well, since we only have 20, I was thinking maybe having both a control and a placebo, but with 20 it'd have to be one or the other.
Yeah, probably a control group.
For equal groups. So it's either like you give one group decaf and the other actual coffee, or you give one group coffee and the other group just water or something.
Okay, I think that's probably a good way to think. Either caffeinated coffee and decaf coffee, or maybe coffee versus water. You have other options too, right? Like caffeinated tea, decaf tea. What would be the benefit of doing caffeinated versus decaf?
Placebo.
Yeah, you're not really well, kind of, really blinding,
Yes.
right? You don't know what treatment you're getting. So when I'm done talking, what you're going to do in your group is decide what are your 2 treatments, how are you splitting up these 20 students into 2 groups, what are you controlling, what are you going to measure, and how are you going to make a conclusion. So take 5 minutes. Please design in detail your experiment. Okay, so we already talked about treatments would be something like caffeinated and decaf coffee. How many people used slips of paper in a hat? Okay, I would say something like, write caffeine on 10 slips, no caffeine on 10 slips. Put them in a hat. What do you have to say?
That you mix them together.
You definitely mix them together. Draw 1 slip for every student without replacement. So if I draw a slip, I throw it away. The other option with the slips of paper is you could write their names. So write all 20 names on a piece of paper, put them in a hat. Did anybody use a random number generator? Okay, and I think I talked to you all. With a random number generator, I would say something like number every student 1 to 20. Use a random number generator with the bounds 1 to 20. Generate 10 numbers skipping repeats. Okay, so those are our 2 groups. What are some of the things that we controlled? What are some of the things we held constant?
The amount of coffee you
Yeah.
given.
Right, every kid gets the same amount of coffee, probably at the same time of day, right? They all have 8 ounces at 10 a.m.
The amount of sleep they're getting.
Okay, we're trying to control the amount of sleep. Anything else?
How much time they I overheard it from these 2, but the amount of time they had to study.
Yes, I heard that as well. I heard over here something like give them a set amount of time to study every day. I heard over here tell them they can't study, or don't tell them what the test is on.
That's like the same test for both.
Yeah, did we say they're all getting the same test at the end? So maybe how long are we doing this for? 1 day? 2 days? A week? 3 weeks? Something like that. We're gonna give them all the same test at the same time and look at their scores. Okay, practically, what are we gonna do when we have these 20 sets of test scores? How are we gonna know if the caffeine had any effect?
Like if the average is significantly higher for those with caffeine.
That's what I am looking for. Calculate the average test score for the 2 groups. And we will compare the averages.
Would it be nice to say something about like getting 20 students on the same education level?
Ideally, that would be the case, yes. I'm just assuming we have 20 students that volunteered for us, but hopefully they're the same education level, yes. Okay. Now, if there is a difference in the test scores between the caffeine and the no caffeine groups, do we know 100% without a doubt that it was due to the caffeine?
No.
Could it be theoretically due to something else?
Yes.
Yes. Okay.
But by
So
controlling as many things we can think of, that it limits the amount of it limits the amount of things it limits it to just whatever we didn't think of.
yes. So this is the last thing. If results are statistically significant, what that means is that any difference in the response variables is unlikely to have happened by chance or by confounding variables. So in the context of our study, what that means is any difference in the test scores was unlikely due to confounding variables. More likely it was due to the caffeine. Okay. That is some of the stuff for experiments. That's about half of the experiment notes. Which means next class we will be taking equally as many